right? So you get access to these services on demand within, let's say, 5 minutes. It will not take more than 5 minutes over the internet only. So this is the most important part, over the internet. All right. So what happens? How does it help you? Let's see. If you have a requirement, let's say you wanted to perform a particular activity. Let's say this activity is data processing, or you want to do some ETL task and you want to do data transformation, let's say. Now, to do this data transformation, because it's a huge data, you need compute. Yes, you will need a good amount of CPU and a good amount of, sorry, RAM, right? Let's say you want 8 cores of CPU and 64 GB of RAM for this data transformation. And on top of that, the data itself is 2 terabytes in size, right? Now, obviously, I need resources to do this. I need a proper resource, that could manage 2 terabytes of data. I need CPU that has 8 cores. I need a RAM worth 64 GB. The machine that I have in my hand is a basic computer with 2 cores of CPU and, let's say, 8 GB RAM and 512 GB SSD storage. Let's say this is what I have at hand. Now, this is obviously not enough. So one thing is out of question, that is, or out of the equation, and that is the device that I have, right? So now I am stuck with no device at all. I have two options. One is to buy a device, all right? Buy a device which is equivalent to this particular configuration that you have here, so that you can, perform the task that you have in hand or at hand, right? The second option is to go to cloud. All right. Now, this is an introduction to cloud computing, but basically what I'm trying to explain to you is how it works. You go to the cloud service like this. You request. What do you request? That I need a machine. All right. The machine should have this much of CPU at least, this much of RAM, and this much of storage. And what happens? The cloud provider will give you this machine. They will deliver you this machine within 5 minutes. You'll have the machine in your hand within 5 minutes, and you can access this machine from your existing computer over the internet. So from your existing machine, you can view this other machine over the internet. And this is what cloud computing does. Using the machine that I have currently, I can explore the cloud computing portal and I can create resources. I can create 2 terabytes of storage. I can create a virtual machine, as we call it, with 8 cores of CPU and 64 GB RAM, right? And I get it within 5 minutes over the internet with zero interaction with anybody, without having to go behind anyone and requesting for something. All right. I don't have to communicate with any human in between. Compare it to the process of buying these resources. First of all, you need funds because you're going to buy the entire system, right? So it's a high or a huge investment that goes into buying a machine that has this particular configuration. It could go in lakhs also, right? So you need to first arrange for the funds. Then you go to the market, you buy it, you bring it back, and more or less it may take days. All right, it's not something that you do within 5 minutes. It may take days, right? So there's a latency. When you talk about getting physical devices, there will always be a latency involved in the process, right? But when you're requesting for the same resource on the cloud, you get that within 5 minutes over the internet with zero human interaction at these funds that you see here. It's compared to these funds, the cost here is negligible, minimal. Why? Because I don't have to pay for this compute. All right. Not as if I'm going to own it. I just have to pay a small rent for this. All right. It's good for scenarios where, let's say, I have this data transformation task at hand and I want some compute resources, right? Obviously, I can do that with the help of a virtual machine. It will give me the resources. I'll do the transformation within, let's say, 1 day or 2 days of usage. My task is done. Then all I have to pay is the rent for those 2 days. All right. That is all I have to pay, nothing else. And that is called as cloud computing, the delivery of resources over the internet. All right. Cloud computing, in very simple language, is delivery of compute resources, networking related resources, storage accounts, analytics service such as Databricks and ADF and Synapse and other services that you would have heard about over the internet, right? On demand and without any human interaction. So you can get all of these resources at a much lesser cost. You have to pay absolutely minimum cost you have to pay in order to get these resources. Clear? All right then. So that is the concept of cloud computing. Now within cloud computing, we have three different types of clouds. All right. We have basically three different types of clouds at hand. What they are is, first one is something that we call as a private cloud. All right. Now you don't have to get confused. The private cloud is nothing but a scenario where there is a company. All right. So this company is there. Let's say this is XYZ. This company created its own data center. All right. And this data center is where they will have all the servers, all the storage, and everything else. Right. So they keep everything in these data centers. And this data center is created by the company itself. All right. So for example, there is TCS. So TCS will have its own data center within its office campus. So it's called as on-premises data center also. All right. Or on-premise. That means it is in my premise. All right. It's in my location. Only my employees can use it. Right. You will not see Infosys or Wipro employees trying and accessing data centers that has been created by TCS. They will not do that. Why? Because the TCS created data centers will be for their employees. All right. It is to provide access, or they do provide access to the users of their own organization. They do not provide access to users outside of their organization. And the creation of this data center to management, maintenance, and everything will be taken care by TCS itself. No other company is going to come and touch and manage this data center for them, right? So these are data centers created by the organization for their own use. First type of cloud is called as private cloud, where the organization creates its own data centers within its own campuses. Second is the public cloud. This is the category where your Azure, AWS, and GCP falls in. All right. These are the examples of public cloud. Why public cloud? Because it is available to the entire public. Everybody can go ahead and use the public cloud. You and I can create a storage account. You and I can go ahead and use Databricks on Azure platform. You and I can go ahead and create a virtual machine on the Azure platform. So it's available for everybody. All right. General public can go and create resources. Now, where are these data centers created? So what Microsoft did, for example, they created these huge data center buildings like this. In that, they have placed thousands of racks like this. And in these thousands of racks, they have multiple servers stacked on top of, one over another in that data center inside like this. All right. So now if you and I have to go and use, I will create a virtual machine. Maybe it is created on this server. You may come and create a virtual machine that will be created in this server. So how it came into existence was that these organizations saw a great opportunity, all right, in this renting business. Until now, we have seen large buildings or office spaces being created and being rented out to multiple companies, right? We've already seen that. What Microsoft thought was, what we can do is now, because creating a data center is something that may take millions of dollars. All right. Data centers are not cheap. You have to actually buy a lot of hardware, and that is not cheap hardware. It's very expensive. The hardware is very expensive. The servers and everything, they're super expensive. All right. And that is why uh, all the organizations, especially the smaller organizations, they cannot afford to build their own data center, right? And we know that there is a boom when it comes to data, right? A data center, it may sound like a place where you keep data, but it's not actually where you keep data. It's a place where you are going to do a lot of processing, you're going to create a lot of resources, you're going to host your applications, right? So data within the organizations are increasing. So that means they will need a data center, whether to host their own applications, manage the data related to it, create their databases, right? And they wanted space, they needed servers, they needed compute power to manage this data, right? Majority of the compute is used to manage data and host applications and whatnot, correct? So what did they do? The easier solution was to go ahead and create this in somebody else's data center. Now I told you Microsoft thought that if people are renting out office space, then they may also be interested in renting out a part of data center. All right, this could be a part with 0.0001% of this entire data center capacity, or 0.00000001% of the capacity, or 5% of the capacity, or 90% of the capacity also, right? So eventually it does not matter how much requirement you have. All you have to do is create whatever resources you want, just pay us the simple rent of the resources that you create. All right, because renting is what you do when you invested a lot of money into creating those data centers. Now you need a return. So the return is the rent that these different organizations will pay Azure, all right, or Microsoft. In our case, Azure is the product. They will pay Microsoft for renting out a small part of this data center. So let's say TCS came, took this space. Infosys came, they took this space. Wipro came, they took this much of space, right? So many organizations, thousands of organizations can come and create their resources on the cloud. All right. What is the benefit? No need to put in a lot of money into building your own data center. No need to put in a lot of money into managing those data centers, right? Because if you talk about the cost associated with a data center, all right, if you have to understand when you create these data centers, whether Azure is creating it for you or you're creating your own data center, there are multiple costs that are applicable. One is called as CapEx. The second is called as OpEx. CapEx stands for capital expenditure. OpEx stands for operational expenditure. All right. Now, what is the difference? If you see closely, CapEx is a one-time initial, that means non-recurring cost. All right. For example, if I have to buy storage devices, if I want to buy servers, I'll not go around buying servers every day for my data center. I just need the server for the initial setup. Once I bought it, I don't have to buy it again. It's like, furnishing your house. When you are furnishing your house, you're getting the interior designing done. If you've bought a sofa worth, let's say, 1 lakh rupees, it's a one-time cost. You're not going to buy a sofa every day. If you've bought a refrigerator, it's a one-time investment. You're not going to buy it every day. What is a recurring cost? That is the operational expenditure. So non-recurring is called as a capital expenditure, the initial large amount of money that you have to put in. And then we have operational expenditure that is recurring in nature. So at your home, what is the recurring expenditure? Electricity bill, water bill, guard charges, right? Maintenance charges. These are recurring bills. All right. So now you understand the difference between capital and operational. So if you talk about data center, CapEx would include cost of servers, storage, the building itself that you created. You'll not be creating the data center building every day. So there will be a lot of money that you have to put into creation of that building itself, right? So such things which have been created at first and they do not need to be repeatedly created. All right. So that is my capital expenditure. Then I have operational expenditure, which is the recurring cost at your home. You may call it electricity, phone bill, right? Internet bills. In the data center, it is again electricity, right? Water bill also. Now you'll ask, why is water being used in a data center? So the simple answer to that question is that water is very important for a data center. All right, because these data centers, they generate huge amounts of heat, and this heat is managed by liquid cooled chambers, right? So they'll cool the water, they'll run it through the entire data center around these servers, it will absorb the heat, and then it will flow out, dissipating the heat, right? So they use these liquid coolants. So water bill will also be there. Internet, all right, internet access should be there. The data center could not be a black box, right? Nothing goes in, nothing goes out, nothing like that. It should have access to the internet so that people can access whatever resources they have created. For example, if you have created a virtual machine somewhere in the Azure, you should also be able to access it, right? For you to be able to access it, it should be available on the internet, right? It should also have internet access. So that is what you have to keep in mind, right? Next, salary. At home, you don't give salary to anybody. But when you've created a data center, there will be a lot of employees that you have to pay, right? It could be as simple as somebody who's working as a guard for that data center. It could be as professional and experienced person as a data center administrator, or let's say cloud engineer, right? Those people you have to pay. So salaries you have to pay. All right. So that is operational expenditure. This is the cost associated with your cloud, whether it's a private cloud or a public cloud. Now, in case of private, let's say it belongs to TCS. TCS will be responsible for CapEx and OpEx both. In case of public, where Azure is providing the data center, I am neither as a person, as a third person who's using this data center, who's responsible to pay for CapEx? Azure. Who's responsible to pay for the OpEx? OpEx? Azure. What do I pay? I just pay the simple rent for my service that I have created. Nothing else. So it's a virtual machine. The rent could be somewhere around, let's say, 5 rupees per hour, like this. You'll find such costs also in Azure. Is this clear to everybody? Yes or no? Any doubts in the two types of clouds we've seen? Now, obviously, public cloud, and then there is another type of cloud. So the third type of cloud is where we say that an organization, for example TCS, they already had a private cloud within their office campuses. They had already created this data center, but now they also look at cloud and they're like, public cloud, and they're like, Azure is also good, we can create some of our resources on Azure also. So what did TCS do? They ended up having the private cloud as well and being a part of the public cloud through Azure, AWS, and GCP as well. Organizations use these clouds, right? They regularly use them. So what is this particular type of cloud called, where you have private also and public also? It is called as hybrid cloud. This is your hybrid cloud. Any organization which has both public and private cloud will be called as a hybrid cloud. Clear? Yes or no? All right. There are many benefits of cloud computing. You get high availability. So when I'm creating resources or when I'm hosting applications on Azure, I get something called as high availability. What does high availability mean? High availability means that whatever resource I have created, whether it's a storage account, whether I have hosted a website, whether I have created a virtual machine, whether I have created a database, all of that is accessible to me all the time, 24/7. It should not work like State Bank of India, where whenever you go, their common response is that the servers are down. All right. So servers should not go down. That is called as high availability, that my application is always up and running. IRCTC, what happens during the Tatkal booking timing? Are you able to access the application? No, that is called as low availability. So with cloud computing, you can ensure high availability by having, dynamic scalability, right? Where you can scale your application as and when the demand increases, so that, it never goes down or it never becomes inaccessible to the users. Then there is something called as fault tolerance also. So these are all different benefits of using cloud computing. Fault tolerance is another benefit. It says that if any fault occurs, cloud computing or the public cloud, right? So when we say cloud computing, we're talking about public cloud in general. Public cloud has got you covered for any fault that may occur. Faults, you can assume it to be, let's say, an electrical fault or an internet fault, right? So what is an electrical fault? That the power is not there. So how does the data center deal with that? They will have multiple power backups, multiple, right? How will they manage internet fault? They will have multiple internet connections. They will have connection from Airtel also, they'll have it from ACT also, they will have it from Jio also, they will have it from Vodafone also, right? So they will have multiple backup options available to ensure that we are ready to deal with any fault that may happen. Clear? Then you have scalability. Scalability is the ability to increase the capacity. All right. Scalability is nothing but the ability to increase the capacity. This capacity can increase in two directions. One, vertical, two, horizontal. Vertical scaling means I had a machine, let's say it had 4 cores of CPU, 8 GB RAM, and 1 TB storage. Vertical scaling means I stretch this existing machine. All right. So when I stretch it, what do I end up doing? I created 8 cores, 16 GB RAM, and 2 terabytes of storage. In both the scenarios, I have one single machine. The only thing is now I have vertically scaled one of the existing machines. This is called as vertical scaling. Horizontal scaling means that is something, horizontal scaling is that something which is very useful for us also. You had one machine and you ended up adding more machines altogether. All right. So vertical scaling, you increase the capacity of existing instance. Horizontal scaling, you add more instances. That is called as horizontal scaling. So I'm adding more machines. Then you have elasticity. Elasticity says that this ability to scale is not dynamic. All right. The ability to dynamically scale yourself, right? Automatically scale yourself is called as elasticity. So in various Azure resources, you will find the ability to automatically scale. I don't need your permission to scale. If the load increases, I will scale on my own. All right. Then you have global reach that says that Azure is present in almost every country, right? They will have data centers in all important countries. Azure has almost 60 plus regions in total. In India itself, there are 3 regions. One is in India South, that is your Chennai. One is in India West, that is in Mumbai. And one is in India South, India Central, that is your Pune region. So 3 regions already exist in India. Why is there a need to create so many regions all around the world, right? As of now, you don't have an idea about it, but I'm telling you, Azure will have data centers in US also, in Canada also, multiple locations in US. If you can imagine, right? 3 data centers in India. So that means multiple data centers in US, multiple data centers in Canada, almost all European countries, important major European countries will have it. You'll have data centers in Dubai, you will have data centers in China, Japan, Korea, right? South Korea, Australia, you'll have data centers everywhere. The reason is that they want to offer local solutions. Local as in, if you would remember, a few years ago, American Express stopped its operation in India. How many of you have an American Express card? Anyone here who has an American Express card? Yes, no, no one? All right. So back in 2021 or 2022, American Express was stopped by the government of India from issuing any new cards. Why? Because they were storing data of Indian citizens, the transaction data, personal data of Indian citizens outside India. And the government made it mandatory for these organizations to store data within India. Correct? So since they did not comply to it, they had to stop their operations until the point where they complied with the government regulations. So each country will have its own government regulations with respect to storage of data, creation of resources, right? Organizations will also have their regulations. So to meet those regulations, right, I cannot have all the data centers within US, right? How are my Indian businesses going to store their data now? If your data centers will be kept in US, how are we supposed to store the data here, right? So to address that issue, it has a global reach. There's a lot of security as well, right? Um, Security, there's several aspects to it, right from the point where you have a gated, a guard present at the main gate, to the security of encryption. There's multiple locations in ways in which security is ensured within cloud. Or like agility, it increases your agility. It lets you do multiple tasks, right? You can do development, deployment, testing all at once. Correct? Then finally, there is a disaster recovery also, which means that in case of a disaster, we'll be able to, recover your data, your resources, and everything. All right. So these are some of the cloud benefits. Now, since this is a demo class, we'll stop here at this cloud benefit, and we'll also see something that we are going to cover in depth, and regularly in the upcoming classes. All right. So any idea what that is going to be? No? All right. So we are going to discuss Apache Spark. What is Apache Spark? Imagine that you have a book like this. It's a large book. It's a giant encyclopedia. And your task is to count right every single instance of the word the. How many times the word the came in that book, right? You could do it. Ideally, you could do it, but it is a very time taking process. You would have to read every page. You have to go page by page from start to finish. You have to keep a running tally where you can keep the current count. And this is how a single computer works. All right. This is also how a single computer would work, right? On a very large file. It is effective, or it can do it, but it is pretty slow because it is solely responsible for the entire transformation. Now imagine that the book itself is just volume one. There are 5 different volumes of this book. Now you're gone. Or let's say it's a library with thousands of books. You're definitely gone. Not possible, impossible for you, right? To go through an entire library of thousands of books, tens of thousands of books, and count how many times the word the came across all of those books, right? That is the reality of big data, right? If I give you a pinch of sand in your hand and I ask you to count the number of particles, you can do it. It's gonna be a very long process. But if I give you the entire beach and I ask you, count the number of sand particles in this entire beach, impossible, right? That is, something what big data looks like. The amount of data is so enormous that a single person or a single computer just simply cannot do the job in a reasonable amount of time. So how do you solve this problem in the real world, right? You would hire one more person, You would hire a team, right? You would have a manager who's going to manage that team, and you will give each person a stack of books, right? So rather than me going through all the thousands of books, I hire a team, let's say of 100 people, and I give them all 10 books, and there's a person who's managing them, right? So what I'm doing, I'm distributing my task. All right. If I'm giving the same task to them, each person would work on their own stack at the same time, right? So let's say I had 10 books, or let's say I had 5 books. Why to draw 10? So this is book number 1, 2, 3, 4, 5. And instead of reading each and every book on my own and counting how many times the word the came here, I hire 5 people and I tell them, you read book number 1, you read book number 2, you read book number 3, 4, 5, like this. Each person will have its own, book, and the chances are that all of them, if let's say each book has similar amount of pages, almost similar amount of pages, that they will, finish the task at a given point in time. Correct? They'll be parallelly processing the data. This is parallel processing that you see, right? Because each person is processing its own data, and all of them are doing it at the same time. And so this is called as working in parallel. Once everybody is finished, they're going to report their individual counts. Let's say person one said that I found this word 600 times. Person B said I counted this word 800 times. Last person says, I counted it, let's say 400 times. And these two, 3 and 4, said that, I counted only 100 times. The book was short, and 200 times, right? So now they will report all of this to one single manager that they have. The manager will receive all the responses from individual workers, right? So 6, 800, 1400, 1500, 1700, and 2100. The manager will have the count of the word in the 5 books that they had, and the count is 2100. So that is how, in essence, exactly what Apache Spark also does. What you saw on your screen is exactly how Apache Spark works. It is a very powerful system which is designed to be the manager and the team also. It's not just the manager. Apache Spark is this entire structure that you saw. All right. So manager and the entire team for processing massive data sets. It takes the huge data problem, breaks it into smaller pieces. So this was my data overall from top to bottom. What did I do? I divided it into 5 parts. I distributed across 5 nodes, right? I'll tell you about nodes and all. As of now, what we did, 5 books were there in total. We divided that workload among 5 different people who performed the analysis in parallel. And then I got the result. If only one person was doing it, he'll do book number 1 first, then go to book number 2, then go to 3, 4, 5. And so the time, let's say they were all able to complete it in 1 hour, right? So for a single person, it would have taken around, obviously more than 5 hours, because they have to go through each and every book at once, right? Cannot do it in parallel. So it breaks the data into smaller pieces and uses a team of computer, right? So here we had a team of humans, but within Spark, we have a team of computers to process this data, all right, in parallel. So what is this team? Let's see. In Apache Spark, the team is very interesting, all right? Why? The first person is the driver. I am writing the here. It's simply the driver. Driver, you can think of them as the head chef. It's the brain of the entire operation. Think of it, as I said, a head chef in a very large and busy kitchen, telling everybody what to do, how to do it, what they have to make, what they have to process. That is exactly what the driver does. The moment I run my Spark application, whatever task I have at hand, the driver program, all right, it's the main program that is going to run that. All right. So it's the driver program that is going to run my Spark application, the head chef. It is going to read the master data. It reads your code from top to bottom to understand what you want to accomplish, what transformation you want to do. It will create a plan. All right. It reads the code. Code is basically where you define the transformation. Let's say you are using PySpark. So using PySpark, you would have defined your data set, where is your data present, what transformation you want to do. So all of that the driver will do. It will create a plan based on what transformations you want to do. It will create a logical plan with a step-by-step plan. All right. This is also called as something that we call as a DAG. We'll come at that later. It's a directed acyclic graph, right? Now, it will first, let's say your program is very simple. It will first read the data from all the files. Second, it will filter out the unnecessary lines. Third, it will count, let's say, the word in the remaining lines. That is what it wants to do, right? So all of this plan will be created by the driver itself. The driver is the one who's going to give out responsibilities to others. Who are the others? Others are the actual workers. Within Spark, what you create is called as a compute cluster. So instead of a single machine, I told you, instead of a one person or a single person doing the transformation, I will have a team of people. So in terms of computer, instead of one computer doing everything, I will have a team of computers here. Like this. This is computer number 1, 2, 3, 4, 5. These are, or this particular entire, all the computers together are called as my cluster. Individual computers here are called as nodes. We call them workers also. So I can say node 1, node 2, node 3, node 4, node 5. Together, this is my compute cluster. Together, they are the cluster of my compute. All right. Now, I will have a separate computer, which is not a worker, but a driver. Already discussed that, right? What is the job of the driver? If this is your data, the driver will basically define the code that you have to, process this data using, right? Now, what data is coming, how it needs to be processed, all of that will be defined in the code. So what it does, it is going to break down, the driver breaks down this data into multiple parts, 1, 2, 3, 4, and 5. And then it starts sending individual data to these individual computes that you see here. So part 1 goes to first compute, part 2 goes to second, part 3 goes to third, fourth goes to fourth, fifth goes to fifth, right? So like this, what I've done essentially now, instead of processing all of the data at once, I am going to process this data in parallel by dividing it into equal number of partitions. I can have 10 partitions also here. 5 is just for your reference. I can have 20 partitions also and 5 nodes doing the processing. So what will happen? First batch will come, they will all process. So let's say if I have 20 partitions, right? 20 parts. So first 5 parts will go, the remaining will be 15. They will get processed. The processed data is sent to the driver, which will compile the output, right? So all the data from all these different nodes have to be consolidated. So it's consolidated it. Second batch, 5 more parts will be sent. Now the remaining is 10. Again, it will process it, append the data over here like this. Again, 5 more will be sent. Now 5 remain. It will process it. These nodes over here will process, workers will process the data, again append it to the final output at the driver, and then the last part will be sent. After that, I have 0 parts remaining, and that will also be processed and appended here. And this is the final data that you have with you. All right. So it will be, when I do 5 parts and 5 computers processing, it is just for your reference. There could be more parts, but that means that they will be then processed one by one. All right. So that is, these are the workers over here. The driver will read everything, create a plan. It will, configure these computes. It will get this cluster ready. It will divide the data, send it to individual nodes within the cluster, and then process them in parallel and collect the response. All right. These are workers. Sometimes we also call them as executors. The relationship between the drivers and the executors or the worker is that of a master slave relationship. We call it the master slave relationship. The worker, the executor, will receive a task, right? It will receive the task from the driver. The task will include two things: the code that it needs to run, which is basically the instruction, right? Through the code, you are going to define the transformation, and the part of data or the piece of data that it needs to run that code using. All right. So what transformation needs to be done, on what data it needs to be done, those two things will be given to a single node. It will do a transformation. It will complete the work. It will perform the calculation, right, on the partition of data that has been sent to it. It will have its own memory also. Each node will have its own RAM, and it will have its own CPU also, right? Because you have these machines. These are your normal machines that you have, right? So they will have their own CPU. They will have their own RAM to do the work, and it does not know, or it does not care about, what is happening with the driver. It is only responsible for what the data was sent to it and the code that was sent to it. All right. Any intermediate result, the executor keeps the result in its own memory, any intermediate. So that is one reason why Spark is so fast, because it makes use of memory rather than disk. All right. We are working with RAM and not disk storage. That is why it is faster. All right. If you compare Spark with Hadoop, because of this fact that it stores data in memory and processes data in memory, Spark in some cases is even 100 times faster than Hadoop. All right, which is actually what Spark claims as well officially. All right. And once the processing is done, it will report all of this data back to my driver. Everybody will report the data back to the driver over here, like this. Clear? So do you understand now the architecture of what is happening here, how it is happening here, how the data gets processed? Right. So it's a brief introduction that I wanted to give you on the Spark architecture. Obviously, there's a lot of other things also that goes into it. It's just, I would say, an introduction to the Spark architecture. There's obviously a lot more, that goes into it. The DAGs, the plan that gets created, how it is executed, right? Uh, how will that happen? All of that we'll have to see in the class itself. Clear? All right. So with that, we'll stop here with the demo session, and tomorrow we'll continue from Azure. All right. I wanted to give you a brief introduction of the Spark architecture so you understand how it actually works. So this is just, very basic outline of it. There's obviously a lot more that goes into the architecture, but it's a very simple to understand architecture. And the best part is that you don't have to manage this architecture. As a data engineer using Apache Spark with Databricks, this cluster and everything will be managed by Microsoft itself. All right. If I have to show you, I think yesterday, uh, we created a Databricks environment. Let me just open it. Let me just log into the Azure platform. Second. All right. So the Azure platform is here. Let's see. Let it just load. If I go to Databricks, this is an IC Databricks service that I had created yesterday. All right. And now one thing that I'll show you is how does it take help from the Azure platform. Now you see there is a managed resource group that got created, Databricks RG, right? And IC Databricks. So there's a separate resource group that got created. What is a resource group? I know you don't have any idea. Think of it like a container of different resources that I create on Azure. If I open this, you will see various resources that get created with the Databricks. All right. There's a storage account that gets created. There's a virtual network that gets created. There's a public IP address that gets created. The others, I'm not sure if you have, understanding of what a NAT gateway or a managed identity is, because we've not discussed it as of now. But these are some of the important terms. So this is the storage account that Databricks will use. All right. So even I'm creating the Databricks, the storage, compute, and every resource will be taken from Azure. So it's like a parasite. All right. It is providing you with the Databricks, the Spark architecture to work with and everything. Databricks one, let's close this. So this is what Databricks environment looks like. And this is where we'll be performing most of our tasks. All right. On the left-hand side, you have your workspace. This is where you create your notebooks and everything. There is a catalog section where you create your databases and everything, right? You can find the DBFS storage, Databricks file system, that we'll also discuss. You'll find it within the catalog section itself. You have jobs and pipelines that you can create here, ingestion pipelines, ETL pipelines. Jobs are basically automated tasks that you can create. And then the compute. Now, compute is the most important part, because this is where I will be creating the cluster that I just showed you. All right. It's the Azure portal is running a little slow today, in my region specifically. So that is why it is taking some time. Let it just open up. So I'll show you how you can create that compute. All right. So if I click on create compute, I have the option to create that cluster. Whatever we discussed now, you will see it in action over here. Give your cluster a name, select the Databricks runtime, right? So the latest one is 16.4 LTS. I don't want to use the Photon accelerator. Now, disable auto scaling. And this is all we need. How many workers should be there? 8 workers in total. All right. So one driver will be created. If you see over here, wait. Fine. It comes on the next step when you create it actually. Total 7 workers will be created. All right. What is the size of each worker? Each worker will have 16 GB of memory and 4 cores of CPU. Now you can create whatever you want. You can create a worker with 48 cores of CPU and 192 GB memory each, right? If you create 10 workers, that is 1920 GB of RAM and 480 cores of CPU. So you can understand the kind of performance that Data Factory is going to give you. Obviously through Azure, but it can give you, right? Here, one worker is 384 GB of RAM and 96 cores of CPU, right? So you can select any simple one. For our purpose, the smallest version that is available is 14 GB RAM and 4 cores of CPU, or 16 GB RAM and 4 cores of CPU, and that is what we are going to work with. The data set also that we are going to use is going to be very minimal. So I can go ahead with a single node itself. I can say I don't need multiple nodes. I need a single node. All right. And this is done. More or less it's done, right? Spark configuration, logging init scripts. I don't want any initialization. So this is done. Tags are basically used for billing purpose. I can give a key and a value here. And based on this, I can filter out my bill towards the end of the month, the Azure bill that I'll get. And there I can, provide some tags to this compute. So I can see when was this compute created and how much cost has been accumulated by this compute, right? And one good thing about these clusters that you create is that they come with this auto closure. So this cluster that I'm going to create, the moment I start it and start running my Spark applications, if it is left idle, that means if I have not run any Spark code on it for, let's say, 120 minutes, it will automatically shut down. Shut down means this RAM and the CPU will be released so that I'm not charged for anything. All right. So if the RAM and the CPU is released, I'll not be charged for anything, and this is how I'm going to create the same cluster that you just saw. All right. In the workspace, I can go ahead and create my notebooks, right? You can click on create, you can create a folder. Git folder is when you want to do version control. You can run queries here, you can create a file, or you can create the most important thing, that is your notebook. And this notebook is where you write your PySpark code or a SQL code also, Java code also, everything you can write within a notebook. All right, so we'll use these notebooks a lot to write the code either in Python, SQL, Scala, R, or even Markdown format for that matter. All right. So this is, a brief introduction to the Databricks platform itself, right? This is where we are going to work, and we're going to use the services. The catalog is again very important because this is where I'll be creating the databases, the managed and the unmanaged table, the Unity catalog, right? All those things. The Hive meta store is present here. Initially, I will not have the DBFS button here. So to activate that button, I have to go to settings. I have to go to advanced settings, search for something called as DBFS here. And there is a DBFS file browser. So currently it is turned off. I'll just quickly turn it on and refresh the page. All right, once you turn on the DBFS file browser, you must refresh your page. So DBFS is like a storage layer built on top of my Azure storage account, right? And this storage is native to my Databricks platform. So if I go to catalog now, I will be seeing a button called browse DBFS now. But it did not get activated. Let me check again. Advanced DBFS. Okay, it's still turned off. Let's turn it on now and refresh the page. So once it refreshes, we'll be able to see that Databricks file system. So if I go to catalog again, I think for some reason it is not getting activated. I think we'll have to wait for some time. The portal itself is running very slow today. I don't know what is the problem. Yeah, it's not turning on. Let's just switch it on and keep it like this for a while and then refresh the page. All right, later on. So this is all, we're going to cover. We're going to cover everything related to Databricks that you see on your screen. Okay, now it is enabled. Now I can go ahead and refresh the page. Ideally, it gets enabled within a couple of seconds only. But as I said, the portal is running a bit slow. Again, not there. Fine, no issues. All right, so we'll stop here. If you have any questions, please go ahead. From tomorrow onwards, we'll have regular classes. So those of you who want to enroll for this particular training, where we'll discuss a lot about Azure and Databricks, right? And trust me, by the end of this session, you will become pros in Databricks, right? You'll know how to run or create compute clusters, using PySpark, how to transform the data, how do you create Databricks jobs, what is the medallion architecture, what is the lake house platform, what are the delta tables that you create, what are managed tables, unmanaged tables that you create, everything. You will have an idea about that. And obviously, a lot of hands-on will also be required from your end. So those of you who want to enroll in this course, please do that now. Within the chat window, you would find the details, right, for enrollment. The link is there in the chat window. If you do not have the link in the chat window, you can contact on the WhatsApp number that is also present in the chat window. If you do not find it, just go to NICIT Academy, right? Just search for NICIT Academy and you will find the numbers over here, right? So this is the number that you have to contact at.
Yes, quick question. So, what's the time from tomorrow? Because
That Yeah, go
is
ahead.
it same time or like it will start from morning?
No, no, it will
No,
be
no, no.
in
Tomorrow onwards, that same timing, but 15 minutes late, 9:15 p.m. it starts.
Okay, because
9:15 to 10:15.
chat
Yeah.
that you, I mean, somewhere I saw it was like starting from morning 7 a.m. or something.
That is data
No, no, no.
engineering.
That is
Okay,
the data engineering course.
correct. Understood.
All right.
And I mean, these two classes were demo classes, right? So basically, we are going
Yes.
to start from beginning only.
Yeah, we'll be starting from the beginning itself. As I said, first the foundations on Azure. We'll understand the Azure platform, what is cloud computing, what is a virtual machine, what is a storage account, what is a data lake, right? Once you understand those services, then only we can move to Databricks, because I showed you, right? If you see here, Databricks is not created on its own. It creates a few Azure resources also. The moment I create a compute here,
Mm-hmm.
you know, the moment I create a compute here, you will see two Linux virtual machines over here, or you'll see one Linux virtual machines over here, depending on the number of workers that we have created.
Okay.
So it
And
will take
mhm.
use, or it will make use of Azure resources only in the backend. It does not bring its own storage or compute or anything.
Got it. Got it. One last question. So, I mean, I was
Yeah,
going through the syllabus that has been shared, right? So,
yeah.
here it says you are going to, the first part is you are introducing Azure Databricks like features and all those things.
Hmm.
And then we are moving to Azure. But now you're saying you'll start with Azure, right? First.
Yes, yes,
And
we'll
then,
start with Azure. Yes.
so how many days it is going to take for
So,
Azure?
uh, within 5 days, within a week, for one
Okay.
week, our discussion
Okay.
will be on
Initial
Azure.
1 week will be around Azure only.
Yeah, because see, storage account and all, data lake and all is also going to be used in Databricks, right? Within
Mm-hmm.
Databricks, I have to mount the storage, I have to connect to my data lake to get the raw data, right? So to do all those things, I should first have an idea as to what a data lake itself is, right? Where do you keep your raw data? So don't think of it like something related to Azure. It is going to help you with Databricks only. It's a base for Databricks.
Understood. Yeah.
Hmm.
Yes,
Thank you.
Shreyas.
Yeah.
Yes, Shreyas, this is Chandra. I have two questions. Number
Mhm.
one, once we complete this training, you support or do you have any materials that you can provide for the certification, database
Yes,
certification?
yes, yes. So after this training,
Like,
you can all, apply for Databricks Data Engineering Associate Certificate. All right. And I'll be
mhm,
providing you with the questions that are asked in the exam, right?
got you. And the other one is I'm working professional, and if I have any real-time requirement scenarios where I need some discussion or some advice or suggestions, you guys
Yeah,
can
sure.
provide that,
Yeah.
or
Yes, yes, yes. Yes.
outside of the
Definitely.
training?
Yeah, yeah. Whatever requirements you have.
Okay, okay. I'm more interested on that because I'm already working on Databricks,
Mhm.
you know, and I have some requirements that I need to work on.
Yeah. So my
And
expertise would be on Azure and Databricks, right? So as
yeah,
long as your question pertains to Databricks, I'll be more than happy to
Y-
help you.
yeah. It's mostly on Databricks.
Yeah, definitely.
I already completed the AG 900 on Azure side, so
Mhm.
I'm
Yeah.
familiar with it.
Then
But
you
I'll
have a
go through
pretty
the
good
training.
idea. I think AZ
Yeah, yeah,
900, you have a pretty good idea as to, at least at a foundational level, right?
yeah,
You
yeah,
can, and all of you, right? After the 5 days of training, all of you can write the AZ 900 certification as well.
yeah. Okay, so the outside of the training, you can provide that support, right? The
Yes,
real time. Okay, all right.
real time
Thank
as
you.
in, aligned with the
Real
training
time, like
itself.
yeah, align with the training. Let's say if I have Snowflake as a source, I would like to get the data from Snowflake as a foreign catalog and through the ingestion or through the ETL pipeline. And those are kind of, I'm more on the data warehouse and ETL side of the, bench. So I already have real-time requirements. That's why I'm trying to take this course. So
Sure.
I have watched your, YouTube videos also, but I
Mhm.
needed a live session. That's why I'm trying to join.
All right. Sure.
Thank you.
1 second.
So anybody have any other doubts regarding the course or training?
Will you provide assistance for certification?
Yeah, that's what he said,
Uh,
right? So
yeah,
yeah, please
questions we'll
answer.
provide.
Hi, excuse me. So I just heard about another data engineering program as well. Could you just elaborate on that as well, please?
Yeah. So see, Databricks is a tool in itself, right? Where you have to have the understanding of a lot of concepts related to Databricks, about PySpark, right? Uh, and in Azure Data Engineering course, we are covering all the services, not just Databricks, right? We are covering, let's say, your data lakes also, your databases also, your NoSQL databases like Cosmos DB. We are covering Synapse Analytics end to end. We are covering Data Factory end to end. We are covering Stream Analytics, Databricks, and a little bit on Fabrics as well. So that is a more comprehensive course. This is more on the Databricks side. So understanding Databricks end to end.
Okay. And could you tell me like what's the tenure, like the time that would be taken for the data engineering program, since this program is for like 45 days?
Yeah. So see, again, now Databricks over here is kind of a specialization in Databricks. All right.
Mm-hmm.
When you go to data engineering, we'll not be studying Databricks to the extent that we are going to cover it over here, right? For example, if I have to create a Azure Data Engineering course, I would be creating it in 50 hours, 60 hours maximum, right? But if I have to just focus on Data Factory, I can create a course worth 30 hours on Data
Yeah.
Factory itself, right? So that is not what we are doing there. So over here, our specialization is going to be Databricks end to end, understanding PySpark, running PySpark code, understanding how you write the PySpark code, right? End to end. But when you're doing Databricks in the other course, right? It's more about, understanding the important services. And then we are not going to spend a lot of time on individual topics because we have to cover other topics also.
Understood. Thank you.
Yeah, so that is more like an wholesome course, but then that is for people who have some understanding of, the Azure platform, the data engineering tools, and they want to, understand the entire infrastructure, the data infrastructure or the data estate, as we call it, on the whole.
Yeah. Thank you for letting me know. Thank you.
Yeah.
Sir, is it Snowflake also sir is
No.
taking? So, is it related
Hmm.
to that one and this one, or this is separate? And for
And
Snowflake,
this is
SQL
separate.
is mandatory.
Yeah.
Yeah, for this we need to learn any Python or any
Yes,
coding.
PySpark. PySpark is important for this.
Okay.
If
Will
you
you
want
cover the
to,
PySpark also,
yes, yes,
or?
yes. PySpark will start from the very basics, and it
Mm,
is as I said, right? We are going to go all out on Databricks, so we need to understand PySpark. If you have the Spark architecture, you also need to know how to talk to it, and that talking will happen through PySpark.
okay, fine. Sir, can we apply a real-time experience after this completion
Yes,
with
yes,
this course?
we'll be helping you with the projects, real time projects.
Okay, fine.
So the course starts tomorrow, right? Same timing, 9:15 to 10:15 p.m. IST. We'll be having these classes, right? So we've not kept it during the dinner timing. It's post your dinner, right? I hope everybody is done with their dinners around 9. So we'll be conducting at 9:15 and having these classes in the night. So
Yeah,
it's a
this is
weekday
only for
course.
Monday to
Hmm.
Friday. So
Yeah,
weekdays only.
weekdays, Monday to Friday, 9:15 to 10:15 p.m. All right. Uh, thank you. Thank you everyone for joining in for this demo session. It was a pleasure having all of you here with us. Thanks a lot for your time and being a part of this demo session. And I hope to see you guys in the classes.
I'm
Thanks a lot.
sorry, Shreyas,
Hmm.
I just have one more question. So
Mhm.
currently I'm in US, and I
Mhm.
was wondering like if you guys can offer me any real-time project experience right now, like help with real-time project experience. Like yeah, like some one of the management could like text me like it's fine since we're about to end the session. I was wondering like do you guys provide any
Mhm.
services like that?
Uh, Not right now. All right. We provide the projects after we've completed the training.
Okay, yeah, that works. Yeah,
Mm. Yeah.
sure. Thank you so much.
Thank you all. Thank you for joining, guys.